Hey, what's up everybody? Today, we're going to do something a little different. We're not debugging code. Nope. We are debugging the single most important tool we use to write code, and that's our own brain. We're about to dive into 3 hidden bugs in our own thinking that make programming way harder than it needs to be.
So let me ask you something. You've been there, right? You've spent hours, maybe even a whole day chasing down a bug. You are absolutely convinced you know which line of code, which function is the culprit, only to find out you were completely, totally wrong. It's so frustrating. But what if the problem wasn't in the code at all? What if the real bug was in how we were thinking about the code?
And here's the big idea, the key to all of this. It's not really a bug in your brain, it's a feature. Our brains are these incredible pattern-matching machines. It's a survival trait, right? It helps us make sense of the world super fast. But when you're staring at complex systems, those same mental shortcuts, those features, can become the worst bugs in our logic, leading us way, way down the wrong path.
Yeah, you can think of it like this. Our brains run on their own kind of code. And just like our software, it has its own logical errors. So, let's fire up our cognitive debugger and take a look at 3 of the most common fallacies that trip up developers all the time.
First one up is what I like to call the timeline trap. This is that classic situation where 2 things happen one after the other, and our brain just instantly leaps to the conclusion that the first one must have caused the second. Now, if you want to get fancy, the formal name is post hoc ergo propter hoc. Yeah, it's a mouthful of Latin, but all it means is after this, therefore because of this. It's this super common bias where we assume that just because event B happened after event A, then A had to be the cause of B.
And here is exactly how this flawed logic plays out in real life. Picture this. Step 1, you push a tiny, seemingly harmless CSS change. You know, just changing a button color. Step 2, 5 minutes later, you get a Slack alert. The login API is down, and your brain just screams, "Oh no, my CSS change broke the entire authentication system." The sequence alone creates this incredibly powerful, but so often false feeling of causation.
All right, our next cognitive bug is a close cousin to the last one. I call it the phantom pattern. This is where our brain's pattern matching ability just goes into complete overdrive.
The technical term for this is illusory correlation. It's our brain's tendency to see a connection, a link between 2 totally unrelated events. Maybe a certain user in Germany keeps reporting an issue every Tuesday. Your brain wants to find a pattern there. You can think of it like a race condition in our own reasoning. We connect the dots so fast we don't even stop to ask if there's really a line there at all.
And now for our final bug. And honestly, this might be the most dangerous one of all, the favorite suspect. It's kind of like being a detective who decides who the culprit is on day 1 and then spends the rest of the investigation only looking for clues that prove they're guilty.
Of course, we're talking about confirmation bias. This is our natural human tendency to search for, interpret, and remember information in a way that just confirms what we already believe. When you're debugging, this creates serious tunnel vision. We come up with a theory, and then, without even realizing it, we start protecting that theory instead of trying to find the actual truth. And we all know exactly what this sounds like inside our own head, right? You just rolled out a brand new caching system, and suddenly something breaks. That first thought that pops into your head is, I'm sure the bug is in the new caching layer. And that one thought, it becomes your anchor.
So, what's the next step? You dive headfirst into everything and anything related to that caching layer. You're digging through the cache hit/miss logs. You're scrutinizing the invalidation logic. You're analyzing the Redis server performance. You are on a mission to find evidence that proves your theory right.
But here's the problem. Here's what you're not looking at. You are completely ignoring that database schema change that went out yesterday. You're blind to that quiet little update to a third-party API. You have no idea about the new firewall rule the ops team just pushed, or that one seemingly unrelated background job that's been failing silently for hours. Your confirmation bias has literally put blinders on you.
So let's just quickly put these all side by side. With the post hoc fallacy, our brain's flawed logic is, hey, sequence equals causation. Simple. With illusory correlation, it's more like, these things kind of feel related. And with confirmation bias, the logic is just, I'm right and I'm going to prove it. They are all mental shortcuts that feel efficient but can lead to disastrously wrong conclusions. Okay, so what's the fix? How do we stop our own minds from leading us astray like this? Well, the solution isn't to get a new brain. It's to start debugging our own thought processes with the exact same rigor that we apply to our code. So here it is.
your new mental toolkit. First, actively question your assumptions. When you think it's the cache, stop and ask yourself, why do I think that? What's the actual evidence? Second, force yourself to come up with at least 3 other possible causes. Third, and this is the big one, this is the game changer, deliberately try to disprove your own theory. Actively look for evidence that you're wrong. And finally, just keep that mantra in your head. Correlation is not causation.
So I'm going to leave you with a final thought to chew on. We've just covered 3 major cognitive bugs today, but trust me, there are a lot more. So ask yourself, what other human bugs affect the way you code? Because just being aware of them, that's the first and most important step to becoming a much better programmer. Happy debugging, both in your editor and in your head. Thanks for tuning in.